Okay, so good day. We we are here to discuss about the NSCP Section 409, which are beams. Our group members are Arcelia, Bolima, Go, and Nazareno. For the scope of the NSCP, it applies to non-pre-stressed and pre-stressed beams such as composite beams constructed in separate placements but resist loads as a whole unit, or one-way joist systems with accordance of Section 409.8 and deep beams in accordance with Section 409.9. For the general instructions, for materials, the design of concrete in accordance with Section 419, the design of steel reinforcements are following the Section 420, and the materials design and detailing requirements for embedment in concrete in accordance to Section 420.7. For connection to other members used in cast-in-place construction, joints should satisfy Section 415. Precast construction connections should satisfy the force transfer requirements of Section 416.2, which means the transfer of forces by means of grouted joints, shear keys, bearing anchors, mechanical connectors, steel reinforcements, reinforced topping, or a combination of the like. For stability, if the beam is not continuously laterally braced, spacing of lateral bracing not exceeding 50 times the width of compression flange, the spacing of lateral bracing considers the effects of eccentric loads. For pre-stressed beams, buckling of thin webs and flanges should always be taken into consideration. For T-beam construction, the flange and web concrete shall be placed monolithically, which means formed by a single large block, following Section 416.4. The effective flange width must follow Section 406.3.2, and the torsional design should follow Section 422.7, and the overhanging flange width used to calculate the A sub CP, which is the area enclosed by outside perimeter of concrete cross-section, A sub G, which is the gross area of concrete section, and for hollow sections, it is the area of the concrete only and does not include the area of voids. For P sub CP, it means it is the outside perimeter of the concrete cross-section in millimeters. For the design limits, the minimum beam depth for non-pre-stressed beams attached to partitions likely to be damaged by large deflections, the overall depth H should satisfy Table 409.3.1.1 unless Section 409.3.2 are satisfied. As seen on Table 409.3.1.1, there is a symbol L which is used, which means L is the span length of beam or one-way slab clear projection of cantilever in millimeter. For calculated deflection limits, non-pre-stressed beams not satisfying Section 409.3.1, deflection shall be calculated with Section 424.2. For reinforcement strain limit in non-pre-stressed beams with PU or the factored axial force taken positive from the compression and negative from tension is less than zero point 0.1 of the FC prime and A sub G, which is the gross area, and eta sub T, which is the net tensile strength in extreme layer of longitudinal tension reinforcement at nominal strength, excluding strains due to effective pre-stress, creep, shrinkage, and temperature, should be at least 0.004.
Section 409.4 talks about the provisions for the required strength. The required strength shall be calculated in accordance with the factored load combinations in Section 405 as seen in the image at the right, and should also be calculated in accordance with the analysis procedures in Section 406. For pre-stressed beams, which are beams that are subjected to initial compression, the effects of pre-stressing should be considered through Section 405.3.11. Next is the factored moment, and it is stated that the factored moment at the support shall be calculated at the face of the support. For the factored shear, it should also be calculated at the face of the support but can also be calculated at the critical section. Critical section is where the critical stress or maximum stress occurs due to loading and forces present. The factored shear at critical section shall be permitted to be designed for sections between the face of the support and the critical section at a distance d from the face of the support for non-pre-stressed beams and h/2 from the face of the support for pre-stressed beams, as long as some conditions are satisfied. Next slide, please. The first condition is that the support reaction in the direction of applied shear introduces compression into the end region of the beam. Next is that loads are only applied at the top surface of the beam or near it. Last is that there should be no concentrated load present between the face of the support and the critical section. As seen in the picture here, the shear Vu is located at the critical section located at the distance d from the face of the support. Similar with the others, the factored torsion should be calculated at the face of the support. The factored torsion at critical section can be designed for sections between the face of the support and the critical section at a distance d from the face of the support for non-pre-stressed beams and h/2 from the face of the support for pre-stressed beams, unless a concentrated torsional moment is present within the distance. If this happens, the critical section should be taken at the face of the support. Next slide, please. So section 409.5 now talks about the provisions for the design strength. NSCP states that the design strength should satisfy these conditions. Phi, which is the strength reduction factor, times the nominal moment should be greater or equal to the ultimate moment or the factored moment. Same goes for the shear, torsion, and axial force as seen here. The strength reduction factor phi shall be determined in accordance with section 421.2, and from what I remember, the values for phi for the moment and axial force is equivalent to 0.90, and for shear and torsion, it is equal to 0.75. If Pu, which is the factored axial force, is less than 0.10 times the compressive strength and the gross area of the concrete, the nominal moment should be calculated in accordance with section 422.3. Otherwise, it should be calculated in accordance with section 422.4. It also states that for pre-stressed beams, unless tendons are effectively bonded through its entire length, external tendons are unbonded tendons when calculating flexural strength. Next slide. Nominal shear should be calculated in accordance with section 422.5. For composite concrete beams, nominal horizontal shear strength should be calculated using section 416.4. And now for torsion, the factored moment is less than the threshold torsional moment times phi, the effects of torsion can be neglected. The nominal torsion should be calculated in accordance with section 42.7. It is also stated that the longitudinal and transverse reinforcement required for torsion shall be added to that required for the factored shear, factored moment, and the factored axial force that act in combination with torsion. For pre-stressed beams, the total area of longitudinal reinforcement at each section should be able to resist the factored moment, mu, and the additional concentric longitudinal tensile force, which is equal to the area of the reinforcement that resists torsion, At, times the yield stress, Fy, based on the factored torsion at the section. If ever the factored moment and the factored torsion happens at the same time, the torsional reinforcement area in the flexural compression zone by a value this much, which is the factored moment, over 0.9 times the effective depth d times the yield stress, it can be reduced by this much, as long as this value doesn't go lower than what was stated for the minimum required in section 409.6.4.
Next will be the discussion on section 409.6, the reinforcement limits of beams. As for the minimum flexural reinforcement in non-pre-stressed beams, AS mean shall be greater than the following equations. For a statically determinate pre-stressed beam with flanged in the tension zone, BW or the width of the web shall be equal to the width of the flange or 2 times the width of the web. If AS provided at every section is at least one-third greater than the required analysis, then the two equations need not to be satisfied. As for the minimum flexural reinforcement in pre-stressed beams, uh, for beams with bonded pre-stressed reinforcement, AS and APS, which is the area of the pre-stressed reinforcement in the tension zone, shall be able to withstand a factored load of 1.2 times the cracking load based on the modulus of rupture in section 419.2.3. Meanwhile, for beams with unbonded tendons, uh, it shall be the minimum AS mean required is equal to 0.004 times ACT, where ACT is the area of the part of the cross section between the flexural tension phase and the centroid of the cross section. For beams with flexural and shear design strength at least twice the required strength, uh, section 409.6.2.1 need not to be satisfied. Next slide, please. As for the minimum shear reinforcement, the minimum area of shear reinforcement, or denoted as AV min, shall be provided in all regions, where VU, the factored shear force, is greater than zero point 0.5 multiplied by the reduction factor times VC, or the stress corresponding to two-way nominal shear strength. If shear reinforcement is required and torsional effects can be neglected, then according to section 409.5.4.1, AV mean shall be in accordance with table 409.6.3.3, which is the table on the right side. Next slide. For the minimum torsional reinforcement, its minimum area shall be provided where TU, or the factored torsional moment at the section, is greater than or equal to the threshold torsional moment multiplied by the reduction factor, as it is in accordance with section 422.7. If torsional reinforcement is required, the minimum transverse reinforcement shall be greater than the equations A and B, the upper one. Meanwhile, if torsional reinforcement is required, the minimum area of longitudinal reinforcement shall be less than both equations at the bottom. Next slide, please. Moving on to section 409.7, which covers the reinforcement detailing of beams. As for the general, the concrete cover for reinforcement shall be in accordance with section 420.6.1. As for the development lengths of deformed and pre-stressed reinforcement, this section states that the specifics of it is found in section 425.4. Meanwhile, for splices of deformed reinforcement in section 425.5 and bundled bars in section 425.6. As for the minimum spacing S, it states that the details can be found more on section 425.2. For the flexural reinforcement in non-pre-stressed beams, the critical locations for development of reinforcement are the points of maximum stress and points along the span where bent or terminated tension reinforcement is no longer required to resist flexure. The reinforcement shall extend beyond the point where resist flexure is no longer required for a distance greater than d and 12 dB, or the nominal bar diameter, with the exemption at the supports of simply supported beams and free ends of cantilever beams. Next slide, please. Uh, the flexural tension reinforcement shall not be terminated or be cut off in the tension zone unless one of these three conditions are met. Meanwhile, adequate anchorage shall be provided for tension reinforcement, where reinforcement stress is not directly proportional to the moment, or some such cases are in sloped, stepped, or tapered beams, or where tension reinforcement is not parallel to the compression phase. As for the termination of reinforcement, at simple supported beams, at least one-third the maximum positive moment reinforcement shall extend along the beam bottom into the support at least 150 millimeters. At other supports, it should be at least one-fourth the maximum positive moment reinforcement, and at least one-third of the negative moment reinforcement at the support must have an embedment length beyond the point of inflection, at least d or 12 dB or ln over 16. As for the flexural reinforcement in pre-stressed beams, external tendons shall be attached to the member in a manner that maintains the specified eccentricity between the tendons and the concrete centroid through the full range of anticipated member deflections. Uh, an external tendon is the rebar or the reinforcement which is not casted within the concrete. So nasa labas siya. And an example of this is seen on the image on the screen. If non-pre-stressed reinforcement is required to satisfy the flexural strength, the detailing requirements of section 409.7.3 shall be satisfied. Next slide, please. As for the longitudinal torsional reinforcement, if it is required, then it shall be distributed around the perimeter of closed stirrups that satisfy section 425.7.1.6 or hoops with spacing not greater than 300 millimeters. Longitudinal torsional reinforcement must have a diameter at least 0.042 times the transverse reinforcement spacing, but it should not be less than 10 millimeters. It shall also extend for a distance of at least BT plus D, where BT is the width of the cross-section containing the closed stirrups resisting torsion, and D being the distance of the extreme compression fiber to the centroid of the longitudinal of the bar. Uh, for the transverse reinforcement, uh, details of it shall be in accordance with section 425.7. If required, shear reinforcement shall be provided using stir-ups, hoops, or longitudinal bent bars. Examples of stir-ups or longitudinal bent bars are seen on the slide. Pag sa column, ang tawag naman dun sa stir-ups is ties. So for the maximum spacing of shear reinforcement, it shall be in accordance with section 409.7.6.2.2 or simply the table on the slide. Next slide. For the transverse reinforcement, uh, it the closed stir-ups should be in accordance with section 425.7.1.6. It shall not it shall extend a distance of at least BT plus D beyond the point required by analysis, and the spacing reinforcement shall not exceed pH over 8 and 300 millimeters, whichever has the lesser value. As for the lateral support of compression reinforcement, the sizes of transverse reinforcement shall be at least 10 millimeters in diameter for longitudinal bars that are 32 millimeters in diameter and smaller, and 12 millimeters in diameter for longitudinal bars that are 36 millimeters in diameter and larger. As for the spacing of the transverse reinforcement, it shall not exceed A, B, and C.
Section 409.8 talks about non-pre-stressed one-way joist systems. Non-pre-stressed one-way joist systems consist of a monolithic combination of regularly spaced ribs and a top slab designed to span in one direction. meaning it is formed as one block, which can be seen in the photos. This is also known as rib slab. The ribs can be tapered and permanent fillers like clay tile filler blocks or removable fillers like steel pans are used to cast it in place. Next slide, please. The following are the limitations of this section. Width of ribs shall be at least 100 mm at any location along the depth of the ribs. Overall depth of ribs shall not exceed 3.5 times the minimum width. Clear spacing between ribs shall not exceed 750 mm. Nominal shear strength V sub C shall be permitted to be taken as 1.1 times the value in section 422.5. One-way joist construction not satisfying the said limitations shall be designed as separated slabs and beams. For structural integrity, at least one bottom bar in each joist shall be continuous and shall be anchored to develop specified yield strength Fy at the face of supports. Reinforcement perpendicular to the ribs shall be provided in the slab as required for flexure, considering the load concentrations, and shall be at least that required for shrinkage and temperature in accordance with section 424.4. Next slide, please. For slab thickness, if permanent burned clay or concrete tile fillers of material having a unit compressive strength at least equal to Fc prime in the joists are used, the slab thickness over fillers should be at least the greater of 1/12 the clear distance between ribs and 40 mm. For calculation of shear and negative moment strength, it shall be permitted to include the vertical shells of fillers in contact with the ribs. Other portions of fillers shall not be included in strength calculations. If fillers not complying with the said fillers or removable forms are used, slab thickness shall be at least greater of 1/12 the clear distance between ribs and 50 mm. Next slide, please. Section 409.9 discusses deep beams. Deep beams are members that are loaded on one face and supported on the opposite face as shown in the figure wherein the top face is loaded and the bottom face is supported, such that strut-like compression elements can develop between the loads and support and that satisfy either one of the following. Clear span does not exceed 4 times the overall member depth h. Concentrated, concentrated loads exist within a distance 2h from the face of the support. Deep beams shall be designed taking into account nonlinear distribution of longitudinal strain over the depth of the beam. This behavior also satisfies the strut and tie models which can be used in design in accordance with section 423. Next slide, please. For the dimensional limits, deep beam dimensions shall be selected such that the factored shear strength is less than or equal to 0.83 of strength reduction factor phi multiplied by square root of SA prime, width of the beam or V sub W, and depth from rebar to extreme compression fiber denoted as D. For the reinforcement limits, the distributed reinforcement along the side faces of deep beams shall be at least that required in the following. The area of distributed reinforcement perpendicular to longitudinal axis of the beam, denoted by A sub V, shall be at least 0.0025 times the width of the beam times S, where S is the spacing of distributed transverse reinforcement, while the area of distributed reinforcement parallel to the longitudinal axis of the beam, denoted by A sub VH, shall be at least 0.0025 multiplied by the width of the beam times the S sub 2, where S sub 2 is spacing of the distributed longitudinal reinforcement. The minimum area of flexural tension reinforcement, A sub S, shall be determined in accordance with section 409.6.1, which was discussed earlier. Next slide, please. Lastly, for the reinforcement detailing, the concrete cover shall be in accordance with section 420.6.1. Minimum spacing for longitudinal reinforcement shall be in accordance with section 425.2. Spacing of distributed reinforcement required shall not exceed the lesser of B over 5 and 300 millimeters. Development of tension reinforcement shall account for the distribution of stress in reinforcement that is not directly proportional to the bending moment. At simple supports, positive moment tension reinforcement shall be anchored to develop Fy at the face of the support. If a deep beam is designed using section 423, the strut and tie models, the positive moment tension reinforcement shall be anchored in accordance with sections 423.8.2 and 423.8.3, which states that the tie reinforcement shall be anchored by mechanical devices, post-tensioning anchorage devices, standard hooks, or straight bar development. At interior supports, the following shall be satisfied. Negative moment tension reinforcement shall be continuous with that of adjacent spans. Positive moment tension reinforcement shall be continuous or spliced with that of the adjacent span.
And we have used the National Structural Code of the Philippines 2015's second printing as reference for our support. Thank you.